Hi, Jim from Ohio here, and I'd like to provide an update on my solar project. And for those of you who watched my last video, you can see that I have mounted some of my components on my controller board behind me, and I'd like to provide an update, let everybody know what I've done so far and why I did things the way that I did. Now, before we get started, I'd like to just mention in advance that I'm not an electrician. I'm simply a do-it-yourselfer like many other people out there. I look on the internet, I do a lot of studying and research to find ways to do things that meet my needs. I try to find ways that are efficient, ways that are inexpensive so that I can do it myself. Now, I'm sure there are going to be some electricians or people much more knowledgeable than I am on this subject, and I just like to mention in advance that if you are going to embark on a project like this, I encourage you and I insist that you go out and do research on your own to ensure that you are doing things in a way that's safe and effective for your particular needs. If you would like to provide some constructive criticism or recommendations on how I can do things differently, or if you see something blatantly obvious that I've done incorrectly, please let me know, and please keep your criticism constructive. I know there are a lot of internet trolls out there, and there's a lot of people who just want to badmouth everything that people do online without even trying to do the things on their own. If you're one of those people, you're welcome to leave a comment, but I probably won't even respond to it at all. Or if you get belligerent or rude in any way, your comment might just magically disappear. So, as I mentioned, please note I am not an electrician. I'd like to emphasize that again. I'm just simply showing you the way that I've done things, and I'll try to explain why I've done things in the way that I have. So before we get started with the project behind me, I'd like to provide a quick update to the Sense home monitor that I spoke a little bit in one of my earlier videos. So let's go take a look at that now. Okay, one of the things that I mentioned with this monitor last time that I spoke about it, there's a screen out here, the devices screen, and I had mentioned that it takes a while before some of the devices in your home are recognized. Well, shortly after I posted my last video, I did get a comment on that video, and it was somebody from the company that makes Sense, and they mentioned that they had done a software update that helps the devices get recognized a little bit quicker. And shortly after that update was installed on my iPad, I did notice that a couple more items did pop into my devices list. And what the new update does is it takes the data that is stored in the server, I guess their company server, that all of the users of this device reports back to. And it uses that data to help recognize the devices in other people's homes. With that said, several devices, new devices, did pop in, and right now I'm up to 13 devices. Now, the thing that's kind of puzzling for me, however, is it appears to me that with this update, it limits the number of devices that the software will display. Right now, I can only see 13 devices, and of those 13 devices that are in here, I've had some devices that were previously shown and listed, and I updated the information as far as the make, model, and identified the device. But then it seems like when a new device was discovered, it would pop in, but one of the previously recognized devices would drop out. So it seems like there's a cap of only 13 devices that it'll show. For instance, if you can see the devices that it has recognized here, you won't see a device labeled coffee maker. I have a Keurig coffee maker, and the possible coffee maker device did show up in this list. I went into the list and I updated it to show that it was a Keurig, and I put the model number of it, and it was in there for a few days, and then later on this device right here that's motor popped in, but I noticed my coffee maker disappeared. Now another thing is I've got these heat devices. Now this is what it'll label a device that it's not sure what it is, but it's some type of a heating device. It can be a toaster oven, it can be one of the elements on the stove, it can be, I imagine, a hair dryer, I'm not sure, but what it does is it initially enters it as a heat device, and then it's up to you to go around your house, identify specifically what that device is, and then update it in this list. Well, some of these devices I've not yet been able to identify, but other devices have come and gone. For instance, at one time I had 5 devices listed in here as Heat 1, Heat 2, Heat 3, and now one of those I was able to detect as being my oven in my kitchen. And so I updated it that way, but since then one of the heat devices has dropped off. So I don't know what to make. I'm not really happy about that. I am hoping they don't cap it to only 13 devices. I'm hoping more devices are detected. But the other thing that was helpful that I noticed was last time that I showed this, I pointed out this screen, which was kind of a breakdown of my home. And these two little things right here, these are the two legs, two 110 legs coming into my house. And you'll notice that they're fairly equal. Looks like this one on this side is 1260 watts in use, and this one's jumping between the high 13s and 1400 watts. Initially, this side over here was much higher than this side. And going around the house, I was able to turn things on and turn things off to determine what was going on. And I found that every afternoon when I came home and I plugged in my electric vehicle, this side would jump up really high. Now, I was able to also determine that I have another high energy use device in my house. I have a crypto mining rig, cryptocurrency or Bitcoin mining rig. It uses about 850 watts of electricity. And it happened to be on this leg too. Now, while they were on two different circuits, they were both on the same leg. And so this leg would be sitting at around 150 to 200 watts. Meanwhile, this one over here would be up over 3,000 watts the majority of the time that the electric car was plugged in. So what I did was that let me know that I was kind of imbalanced in the load on my house. So I went into my AC panel and found the circuit breaker that my electric car was plugged into. And I have an old AC breaker panel. It's not a square D, it's an old push-o-matic. But my electric car used to be on this circuit right here. Well, what I was able to do was move it over to this circuit right here. So I just flip-flop. Both of these are 15 amp circuits, and so I just flip-flop the two wires, and that moved the electric vehicle from this leg of my circuit breaker panel to this leg, and that balanced the load. And so that's what is really nice about having a monitoring system like this. You can adjust it, and that's what I wanted to do so that when I do hook up my solar panels, I'm able to distribute the solar load to make most use in the household. So enough with the Sense monitor, and if that company's listening, I hope that you'll be able to answer my questions or provide some more comments. So let's move over now to the controller panel that I started working on, and give a little update there. Well, the first thing that I did, I don't know if you watched the last video or if you remember how my wall looked, but this piece of conduit was not here, this outlet was not here, and this box was not here. So when I went into my breaker panel to flip-flop those two circuits around, what I did was I went ahead and I installed a couple new breakers. And as I mentioned, these are square D. I don't have these labeled yet, but these are two new Pushmatic 15 amp breakers. Actually, this is a 15, this is a 20. But those I installed, and that is what runs through this conduit. And so this is going to be a 20 amp circuit, and it's a dedicated 20 amp circuit. That will be the only thing that's on that breaker, and this circuit will feed this device when I'm ready to start wiring it and getting it online. And then I have a second cable that runs over to that 15 amp circuit, and this is going to be a dedicated 110 outlet for this device right here, which is my Grid Tie Inverter with the limiter. Now, before we get into what I did or why I did, I'd like to kind of point out one of the mistakes that a lot of newbies make, and I've seen some of those people make mistakes in their videos, is they fail to accurately match the inverter with their solar panels. So we want to ensure that we're using the correct wire sizes and fusion sizes for my particular system, so that everything's done safe and we know that this inverter will work well with my panels. So a little bit about the solar panels I'm using. I'm going to be using 4 solar panels for this inverter, and the panel specs are they're going to be 4 255 watt panels, and the amperage, the P max, which is the most that they'll put out when the sun is highest in the sky, so under optimal situations, they should put out 8.5 amps each. The voltage of those at power max is going to be 30 volts each. So keeping that in mind, we want to now consider what this device is looking for. Now, there are a couple different versions of this Grid Tie Inverter that is on the market, and the particular one that I have is a 1 kilowatt or 1000 watt inverter, and it runs but it is expecting between 45 and 90 volts. Now, there are some that will start up at much lower voltage, but this particular one is rated between 45 and 90 volts. So we're going to be looking at a minimum of 45 volts and a maximum of 90 volts coming from the solar panel, so that this operates the way that it is meant to operate. We'll talk about that a little more later on when we go to configure the solar panels outside, but for right now we're only going to work inside, but we know what some of those numbers are that we need. So the rule that we want to follow is if we were to connect, or the rule to follow with solar panels are, if you connect panels in series, it'll increase the voltage. While if you connect solar panels in parallel, it'll increase the amps. So typically you'll want to raise your voltage as high as possible, since you can use smaller cable sizes, and because cable is one of the most expensive parts, especially if you're running a long distance, you want things to run as efficiently as possible and as cheaply as possible when you're buying the cable. So if we wanted to go the most efficient method, we would connect all 4 of those panels in series. However, if we did that, that would push the voltage, since each of those panels runs at 30 volts, so 30 times 4, that would put us at 120 volts. While that's efficient and we can use a small cable size, this device right here maxes out at 90 volts, so we've got too much voltage if we hook everything up in series. On the other hand, if we connected them all in parallel, it would keep it would push our amperage up to 34 volts, and that would require much larger, more expensive cables coming in from the panel to handle that amperage. Plus our voltage would only be 30 volts. That's what one panel would be, which is much lower than the 45 volt minimum this device is looking for. So to compromise and get things into the proper limits, what I'm going to do is connect 2 pairs of the panels in series, and then I'm going to connect those 2 sets in parallel. And what that'll do is that'll give me 60 volts coming in at 17 amps from the panels when they're maxed out at their highest power output. So now that we know that, we can determine the wire and fuse sizes to use. Now, if you're doing this on your own, as I mentioned, you should conduct your own research online to ensure that you're using the correct items for your installation, because there are other things that play into the mix. Your particular panels may be different from mine. The inverter you get may be different from mine. And the distance between the panels and this inverter comes into play too when you're talking about power loss over great distances. So for my particular installation, I could have gotten by with 12 AWG wire size. However, I did decide to upgrade it a little bit and use 10 AWG cable because it's able to handle a little bit more current over a greater distance with less loss, and it wasn't really a whole lot more expensive than the 12 AWG cable was. So now that we know what wire size to use, I can set up the first device where the solar comes into the house. And I can't emphasize this enough. The first device that it comes into should always be one of these, and this is simply a quick disconnect switch. I mean, these things only cost about $6 or $7 at your local hardware store. There's no reason not to use it. What you can do is, once you have it wired up, if you ever want to work on anything inside, rather than having to run outside and disconnect things, you can simply pull this plunger and it disconnects the solar panels from everything that we've got here. It's a lot quicker than running outside. So the way that this is wired up is very, very simple. My wires coming in from the solar panels, which I do not have yet, will come in and will connect to these 2 lugs right here. And then coming off of the 2 central lugs are my cables that will run over to the next device, which is over here, and that's what we'll talk about next. But as I mentioned, I can't emphasize enough. Please, please, please spend the extra few dollars to be safe and get yourself a quick disconnect switch. They'll save you a ton of time, and you risk damaging your equipment. You eliminate the risk of getting shocked. You risk, I know a lot of people will plug their panels directly into the inverter, and when they do that, sparks always fly. Anytime you've got sparks, you risk burning a component up. And I really think that's why several of the people that I've viewed online that had problems with this, I really think that that's the problem they had, is they're connecting their panels directly to it. You're shorting something out or causing some type of I'm drawing a blank on what I'm looking for. Just a surge of energy is hitting the components inside, and it's causing the components to fail. So this will help eliminate some of that risk. Now, the next item in the circuit is, when we come off of here, we're going over to this, and this is simply a very cheap box that I ordered from China, and I want to say they're about $2 each, and this is something you probably don't need to have. If you only want to have the quick disconnect, that'd probably serve your needs good. But I wanted that extra layer of protection, so I added a circuit breaker. So what I've got, and this is, I know there are American components that are out here that are probably better than this. This is a Chinese circuit breaker. It was cheap, and it should be effective for my need. Now, when you get circuit breakers, it is important. This is DC power coming in from the solar panels, so we want to use a DC circuit breaker. There is a difference in a DC versus an AC circuit breaker. Now, doing the math that we did earlier, I know that I should have at max power coming from the panels about 17 amps. So what I did was I installed a 20 amp circuit breaker. These usually come in increments of 5, so if I would have gone with 15, that would have been too low, where 20 is the next stop up, so I went with a 20 amp. And what this will allow me to do is I can shut everything down here, or I can use the on and off switch here to shut everything off here. The nice thing about it is if there's ever a surge of energy that comes in from the outside, it should kick into the breaker functionality, and it should shut itself off automatically. Now, speaking a little bit about that, a circuit breaker will usually act kind of like a fuse in that it's very slow. A lot of fuses don't go right away. Sometimes they'll heat up, and it may take several seconds before it actually trips the breaker. And that several seconds of extra or energy that surges into the line could be enough to damage this circuit. So after the circuit breaker, what I have are these right here. These are surge protection devices. I've got one for the positive and one for the negative. So what we have is the cables come from here over to here, but then there are a couple leads that come off of here over to this device, and then it comes out of this device and goes directly to ground. So basically what happens if a surge of energy, say I'm going to use the example of a lightning strike nearby. I'm not going to say a direct lightning hit because I doubt that this would handle a direct lightning hit. But if we have something nearby, that surge of energy is going to come in, but it may be too quick for this device to catch it. So instead of sending that extra power to here, electricity works just like water. It's going to take the quickest route to ground. So it's going to go through here and be grounded out with the ground cable that's connected here. So that's about all that I'm going to cover in this video. I think that's quite a bit that I've gone over. Once it leaves here, we are going to go up to these cables, and this is the input side of this inverter. Now on the output side of the inverter, typically what you'll see people do is just take the power cable coming out of it and go straight down to an electrical outlet, which is probably okay. But like a surge can come in on the input side, we could also get a surge of electricity coming from our circuit breaker back through the electrical cable and the outlet into this. Surges happen in houses all the time. So what I'd like to discuss in the next video are the components in this box. And so this is the input side from the solar panels going into this, but we're going to come out of here, we're going to go into this side, which is going to protect things from coming back through our electrical panel and zapping things in this box on the output side of it. So come back and watch that next video. I know this one's been kind of long-winded, but I think it's good information that I know that I wish I would have had a long time ago. It's taken a lot of time to figure out what exactly I needed and what was recommended. Now once I post this video out, I will put the sources for some of these devices, where you can order these, and I'll also put the model numbers of the devices I'm using. But as I mentioned, do your own research to make sure that you're sizing the components for your particular situation. Well, I hope this video has been helpful. If so, give me a thumbs up. If you have other questions, post them down below. If you have comments or things you see that I've done wrong here, let me know about those too, and we'll catch everybody in the next video. Take care and have a good week.